Hello again, friends. I hope you're all doing well. Today we are reaching to section 5 of chapter 5. It is about the integral of 1 over u du. How do we integrate that function that we have got? In general, previously we have studied the integration of a constant function. Okay, we have studied that integration. If we have got k dx, what is that equal to? That is kx plus c. We have studied integration of a power function x to the power of n dx, where n is not equal to -1. What does that equal to? We said we are increasing the power by 1 over the same power plus c. We've studied the integration of trigonometric functions, okay? Sine, cosine, tan, cotan, secant, and cosecant. We have studied those functions, and then after these ones we studied the properties of linearity of integration. We said integration is distributed over two functions when they are summed or subtracted from each other. We said if you have got integration of constant multiple, that means if a constant is multiplied to a function, how do we deal with it? We've studied all those properties. And then later on we came to the substitution method. What was substitution method? Substitution method was a method used for some kinds of integrations that were a little bit complicated. We were using substitution method to change the integrations that we had, the complicated integrations that we had, back to their simple ways, like we have studied previously in the first section, and then integrating it, then changing the integration from u back to x itself. Because in general we were substituting, we were letting u equal to a function of x, and then we were starting to solve the integration that we had. Okay, and then later on, after the substitution method, we studied the area between, or first we studied area under a curve. That means we were having a function, okay? We had to find that area that was given under the curve and above the x-axis or below the x-axis. We were integrating this one. That integration was called a definite integration. Why definite integration? Because we have got limits, upper and lower limits, for the integration that we had. Of course, solving a definite integration is the same thing as indefinite integration. Indefinite integration is the kind that has got no limits here. Okay, we were solving it the same way, but instead of writing that c in here, we were inputting that b and that a into the function that we got from the integration. Then we studied area between two curves. Area between curves. In area between curves, what did we have? We had two functions. We were finding the area between them. We've studied the steps to do for finding the area between curves. First, we said we have to find the bounds for the integration by intersecting the two functions, or we can say by equalizing the two functions to each other, getting an equation and solving the equation. And then we were getting a function inside the integration, solving it, getting the result of the integration. Today we are studying the integral of 1 over u. That means the situation where we have got, let me make it simpler for you before going to that, 1 over u du. If I have got 1 over x dx here, when we were talking about a power function x to the power of n, we said that n must not be equal to 1. N is not equal to, -1. Why it shouldn't equal to -1? Because if you look, when you're solving the integration, if you put -1 into here, we will get something undefined. So here is the case where n is equal to -1. Okay, in that case we get we have got a special case that this integration is equal to ln of absolute value of x plus c. Why? Because ln of x is equal to what? the derivative of ln of x is equal to 1 over x. We said integration is anti-differentiation. So when we look backward, when we think backward, the derivative of ln of x is equal to 1 over x. Why do we put that absolute value in here? Because ln doesn't take negative values. It will be undefined. So that x in here may have a negative value. We are putting that absolute value in here so that we will never get negative values for that x and not make the ln that we have got undefined. And of course, x in here is not equal to 0 because it's in the denominator. It's not in the domain of the function. Now we are coming to the case if you have got in general 1 over u, okay? If you have got integration of 1 over u du, that's equal to what? Is equal to ln of absolute value of u plus c. What's the difference between this one and that one? Of course, in here I have got the function is x. What's the derivative of x? It is 1. I have got the derivative of denominator in the numerator, so it is equal to ln of absolute value of x. Here I have got the general function in the denominator. It's not just x. Maybe it is x squared, sine of x, e to the power of x, or any other function that is in the denominator. So I'm describing it in general as u. If we have got the derivative of denominator up in the numerator, look, u du is in the denominator, I mean in the numerator, then we will get that the integration is equal to ln of absolute value of u plus c. Let's move to the examples that are given in your course material. The first example that we have got, example 3, it is written. Here we have got integration of 2x over x squared minus 5 dx, and the integration bounds are is running from 0 to 2. That means the limitation is 0 and 2. How do we solve that integration? As we said in here, I have got u is a general function in here in the denominator, and I must have the derivative of u in the denominator. If you look at that function, x squared minus 5, what is the derivative of that function? It is 2x. Do I have 2x up in the denominator? I am in the numerator. That's u prime, that's u, and that's u prime. Yes, I have it. So I will directly say that this integration is equal to what? Ln of absolute value of the denominator. Look, u, I have got it here. Then it will be ln of u. So x squared minus 5 is the u that I have got here. So what will I have? I will have ln of x squared minus 5 in the absolute value. But here I'm not writing plus c. Why? Because here I have got definite integration and that one is indefinite integration. So directly the bound is running from 0 to 2. What does that mean, the bound is from 0 to 2? That means first I'm inputting this one into the function and then that one into the function. So that one in general will be ln of absolute value of 2 squared minus 5, okay, minus, because we know that if we input this one into the function and then before inputting this one into the function we have got a minus, then of absolute value of 0 squared minus 5. Okay, so that one is equal to what? Ln of 2 squared minus 5 is equal to negative 1. Negative 1 inside the absolute value is equal to what? Is equal to 1. Okay, so that will equal to ln of 1 minus, and ln of negative 5 inside the absolute value, it will be ln of 5. Ln of 1 is equal to what? Is equal to 0 according to the properties of logarithmic functions, minus ln of 5. So in general the result is negative ln of 5, and that is the result. Okay, so in general what we have got here, we have got a function in the denominator. If we have got the derivative of that function, or we could construct a derivative for the function that we have got in the denominator, we can directly say that that integration is equal to ln of absolute value of the denominator. Okay, let's move to another example. We've got example integration of tan, cotan, and these ones. It's not written as an example, but as a title, okay, integration of tan of x, okay, I've got cotan of x, secant of x, and cosecant of x. So let's find the integration of tan function first. So I have got integration of tan of x dx. How do I solve this one? I know that tan is equal to what? It's equal to sine over cosine all dx. Okay, I'm writing the dx right there. If you look at that function, what do I have? I have got in the denominator cosine of x. What do I have? In the numerator, I have got sine of x. What is the derivative of cosine? Of course, the cosine is the u function. I must look for the derivative of cosine up there, u prime. What is the derivative of cosine? Okay, cosine of x. If I want to take the derivative of it, that's equal to what? Negative sine of x. So what is missing in here? Negative is missing here. But it is okay because I can multiply or construct that negative into there. So I will say that this one is equal to negative integration of negative of sine x over cosine of x dx. You're already familiar with that situation when we are multiplying the function. It's like we are multiplying the function by a positive sign because negative multiplied to negative is positive. But I need a negative inside the integration, so I will leave a negative outside the integration. Now, if you look at here, I will write for you, negative is missing, okay? When we are looking for the differentiation, minus is missing. So we constructed that minus and we put it inside there in the integration. Okay, now if you look at this one, I have got u and I have got the derivative of u that is up in the numerator. Since I have got the derivative of denominator up in the numerator, so I have got a negative sign here, and I will say that that's equal to ln of absolute value of the denominator, cosine of x. Okay, the minus is from the outside of the integration. That one is the derivative of the denominator, so the integration is equal to the ln of the denominator. Now, if you remember from the properties of logarithmic functions, if you have got power in for the function that's inside the ln, it comes in front of it, and if it is here, I can take it back to there. Okay, so if it is here, I can take it in front, and if it is in front of ln, I can take it back to the power of the function that is inside the ln, or the piece that's inside the ln. Okay, how this one will happen? That will be cosine of x to the power of -1. If you have got a negative power, what will happen to the function that we have got? It will become upside down, or here I have got just numerator, it will come down the denominator. Okay, if you remember from the properties of or not the properties, from the definition of the trigonometric functions, 1 over cosine of x is which kind of function? It is secant function. Okay, so ln of 1 over cosine of x, I know that 1 over cosine of x in the absolute value, according to the definition of secant, it's equal to secant of x. So the result of this one is ln of secant of x. Here we have forgotten to write the c. Okay, so I have got plus c, and here of course ln of secant of x plus c. So that's how the integration of tan function is described. Let's move to the cotan function. I have got integration of cotan of x dx. We will do the same operation that we did for tan function, except here cotan is defined as cosine of x over sine of x dx. Now if you look at the numerator and denominator, I have got u from the denominator. What is the derivative of sine function? U prime. It is cosine of x. So I do not need any negatives, any numbers here. So I directly have got the derivative of denominator in the numerator. So that one is directly equal to what? Ln of the absolute value of denominator. Okay, sine of x, and that's plus c. And that's the result for integration of cotan function. We have got, in general, these two is given the integration of this one, and that one is given to in a box in the course material. You can memorize it, but I think it would be better for you to do the steps, because if I ask you to find the integration of tan, you have to do the steps for me, not just directly writing the answer for me. So finding and doing the steps is better than just writing the result. We've got another example here, example 4. It's required from us to find integration of tan of 2x dx, and the integration runs from 0 to pi over 6. Now if you look at that integration, again we are changing this one, that's from 0 to pi over 6. That will be sine x over, sine of 2x, because here we have got 2x, over cosine of 2x, and we have got dx. What is the derivative of cosine? Derivative of cosine 2x, if you want to take the derivative of this one, that will equal to minus sine of 2x, and then the derivative of inside is equal to what? Is equal to 2. Okay, the derivative, we have to also consider the derivative of inside the the angle of the cosine, so that is 2. What is missing in here? A negative sign is missing. Okay, a negative is missing, and 2 is missing here. So I have to multiply that integration by what? I have to multiply it by negative 1 over 2y, because I need negative 2 inside the integration, like that. Okay, I need this minus 2 to be right next to the sine 2x, so that I can say the derivative of this one is up there in the numerator. So for having this negative 2 here, I have to multiply the integration by minus 1 over 2. Now I have got what? The derivative of denominator up the numerator. So this one is equal to minus 1 over 2 ln of the denominator, that's cosine of 2x. Where is the integration? Pi over 6. How is the integration? It is from 0 to pi over 6. So once you're putting ln of cosine of 2 multiplied to pi over 6 into the function, and then minus ln of absolute value of cosine of 2 multiplied to 0 into the function. Okay, applying this one, finding this value, that will be of course pi over 3, cosine of pi over 3 and cosine of 0. You're finding them, putting them inside the ln, you will get the required result for the integration. This one you have to continue it yourself, it's just the evaluation, nothing more. Okay, we've got so far what we have studied the integration of 1 over u du. How about if you have got an exponential function inside the integration? That means, the integrand, the function that we have to find its integration, is an exponential function. How do we deal with it? First, of course, we are starting with the special case when we have got e, because it's easier to consider, easier to see the result. Then we are going to the integration of a general exponential function. So we have got the integration, anti-differentiation or integration doesn't make a difference. Okay, integration of natural exponential function. Okay, so what do we have here? We have got integration of e to the power of u du is equal to e to the power of u plus c. What does that mean? That means if I have got a function, e as a power to the power of u, okay, u is any function, and I have got the differentiation of that u right next to it, then the integration is equal to e itself plus c. Let's start with the simplest example. Okay, what do we have? We have got integration of e to the power of x dx. If you look at that function, it's of the simplest form. I have got the function here is x. What is, that's the u, of course, that we have got. What is the derivative of u? It is equal to 1. So 1 is right next to e because it's not multiplied to anything. So that means there is 1 present here and it is multiplied to e. Since we have got the derivative of x right next to it, so that integration is equal to itself, okay, whatever is the power plus c. That is the simplest form of the exponential function that we have got, integration of the exponential function. Now we're coming to the examples that are given in your course material. We've got example 3, part A. Integration runs from 0 to ln 2 e to the power of 3x, and then we have got dx. What is the u that is present here? It is 3 to the power 3x. What do we have? Or what must we have? We must have the derivative of u right down next to the e. What is the derivative of 3x? It is equal to 3. So I need 3 here, okay? 3 is missing in here. How do I make that 3 here? Like we did previously in the examples, we added the negative and the 2 to it. So I'm multiplying the integration by 3 over 3. I'm taking 1 3 inside and leaving the 3 in the denominator outside. So that one will equal to 1 over 3 integration running from 0 to ln of 2 e to the power of 3x, and that is multiplied to 3. If you look at here, I multiplied and divided the integration by 3. I took that 3 inside, okay, it was here, I took it inside. Why? Because I needed, as this one is the derivative of the power of the exponential function, and I left 1 over 3 outside because I do not need it. Okay, it was just for making my work easier. Okay, now I have got the derivative of the power right next to the e. Since I have got this, so the integration is equal to e itself, e to the power of 3x, and I have to put the bounds also from 0 to ln of 2. Now we are inputting those values into here. That will be 3 ln of 2 minus e to the power of 3 multiplied to 0. E to the power of ln of 2 to the power of 3, because as we know that according to the rules of logarithmic functions that 3 will come to and be the power of 2, minus e to the power of 0, because 3 multiplied to 0, it is 0. Now these two, since they are inverses of each other, so what will remain here? That will be 8. Okay, sorry, here I have forgotten that 1 over 3 to be written. Okay, 1 over 3. Here I have got 1 over 3 multiplied to here, and here 1 over 3 multiplied to that bit, so I have got 1 over 3 here. Okay, now this one is what? That one is equal to 8 minus e to the power of 0 is equal to 1. So that will be 1 over 3 multiplied to 7, and that will be 7 over 3, and that's the required result. Okay, part B, we've got integration from 0 to pi over 2 e to the power of sine x multiplied to cosine x all dx. U here is the sine x. Okay, what is the derivative of sine of x? Is equal to cosine of x. Is it right next to the e? Yes. So since we have got the derivative of the power right next to the e, so that integration is directly equal to what? Is equal to e itself. So that will be e to the power of sine of x we didn't need to multiply, do anything to that function, because we directly had this one here. So that will equal to from 0 to pi over 2. Now we are inputting those values into here. E to the power of sine of pi over 2 minus e to the power of sine of 0. Sine of 90 degrees is equal to what? Is equal to 1 minus e to the power of, here, this one is equal to 1. Okay, so that will be e to the power of 1. Okay, e to the power of 1 minus e to the power of sine of 0 is equal to 0, that is 0. E to the power of 1 is equal to e to the power of 0 is equal to 1, and that will be the required result. Now we are coming to the integration of an exponential function in general. If I have got a to the power of u du, that one is equal to what? Okay, what did we have previously? We had e to the power of u. Now I have got a to the power of u. If I have got a to the power of any function, and again if I have got its differentiation, its derivative right next to it, that integration will equal to 1 over ln of the base, okay, whatever that base is, it will be ln of the base multiplied to a to the power of u plus c. So it's again equal to itself plus c, but here the only thing that makes different between this one and the natural exponential function is that bit. The exponential function is multiplied with 1 over ln of a. Let's move to the examples. Example 5 is given to you. Part A, B, C is the differentiation of the exponential functions that we have already studied in the previous chapters in differentiation part. So I will move to part D, that's about integration. 2 to the power of x dx. If you look at that function, it is 2 instead of e. What do I have? I have got 2 to the power of x. So the base of the exponential function is 2. I have got, instead of u, I have got x. What is the derivative of x? It is equal to 1. It's right next to it, okay? It's like it's multiplied to 1, so the derivative of this one is u prime. Okay, I have it right next to it. So what is that integration equal to? It is equal to 1 over ln of the base, that means ln of 2, multiplied with the exponential function itself plus c. That's it. Part E, we have got integration of 2 to the power of sine x cosine x dx. If you look at that function again, the exponential function has got the base 2. I have got the power of the exponential function is sine of x, and I have got its derivative right next to it. So again, that integration is equal to itself, that means 2 to the power of sine x multiplied to 1 over ln of the base, and that's all plus c, which is the required result. Okay, we are coming to the last example that's given in that section, but it is not related to these ones. To exponential functions, it's related with logarithmic function, but it is an easy one. We've got integration of logarithm of x with the base of 2 all over x, and that's all, of course, multiplied with the dx. If you look at that logarithmic function, it is better to use the rule of change of base. How do we use the rule of change of base? If you remember, when we had logarithm of a with the base of b, we said this one is equal to ln of a over ln of b. So can I change that integration? Yes, of course we can do it. That will be integration of ln of x over ln of 2 over x. Okay, so I changed that logarithm according to the rule of change of base to ln of x over ln of 2 according to that rule, and that's all multiplied with dx. Ln of 2 is a constant number, so I will take it out. That will be 1 over ln 2 integration ln x over x dx. Okay, because that one is moved out. That will be to the denominator will be 1, so that will be ln of x over x. If you look at that integration, I will rewrite it, okay, so that you can see it better. Integration of ln of x multiplied to 1 over x dx. Okay, if you write the integration this way or that way, it will be the same thing. That's not addition, it's multiplication. Why? Because when you multiply it, you will get back this one. Here you can use substitution method, or you can directly say that I've got the derivative of this one right next to it, so I will increase the power. Okay, so here I will use the substitution method, and I will let u that's equal to ln of x. We said when we are doing substitution method, the step right next we should find the derivative of u. So du is equal to what? That's equal to 1 over x dx. Now we are changing the integration, so that will be 1 over ln of 2 integration of, instead of ln of x, what do we have? We have got u, okay, and instead of 1 over x dx, what do we have? We have got du. That integration is equal to ln of 2, 1 over ln of 2. Here it's like x dx, so we are increasing the power. That will be u squared over 2. I will simplify this one. That will be 1 over 2 multiplied to ln of 2. I will write it like that. Okay, so that will be multiplied to u squared. Of course, we have to change the u back to its x form, because the integration of is given to us in x form, so the solution must also be in this form. So that will be 1 over 2 ln 2. Instead of u, I have got ln of x all squared, and of course all plus c, because that is the indefinite integration, so we have to add c next to it. That's all you have got in that section. Section 5 and section 6, they are merged together in that PDF that is uploaded for you. So section 5 and 6, it's about the integration of 1 over u, integration of tan, cotan, and trigonometric function second and cosecant. We have got the integration of natural exponential function first, and then we studied the integration of an exponential function in general. How do you deal with them when it is given to you to be integrated? I hope you would understand the subject. Have a good time, and bye-bye.